Students, today activity, how do you prove that resistance of a conductor depends upon its length? So we know that resistance always directly proportional to length. That means if length increases, resistance of the conductor will also increases. How do you prove? It will prove with a simple activity. So with a small circuit, so this is the circuit, battery, and consists ammeter and the key. These are the 2 points P and Q. When these are will be open, no current flows in the circuit. So what are the apparatus we have to take? Battery, ammeter, key, so and the conducting wires. These are 2 points. Initially there will be no contact between them, there will be no connection. So when the circuit becomes open, take some manganese wires of different lengths. Let us say 10 centimeter, 15 centimeter, 20 centimeter, 25 centimeter and 30 centimeter. But different length, but same cross sectional area. Same area of cross section. ఇక్కడ మీరు గుర్తుపెట్టుకోవాల్సింది ఏంటంటే ఏరియా ఆఫ్ క్రాస్ సెక్షన్ సేమ్ ఉండాలి, లెన్స్ డిఫరెంట్ ఉండాలి. అలాంటి మ్యాంగనీస్ వైర్స్ తీసుకుని ఇనిషియల్లీ కనెక్ట్ ఏ కండక్టర్ ఆఫ్ 10 సెంటీమీటర్ 10 సెంటీమీటర్ లెంత్ 10 సెంటీమీటర్ లెంత్ ఉన్న వైర్ ని పీక్యూ మధ్యలో కనెక్ట్ చేసి ప్రెస్ ద కీని ప్రెస్ చేయండి అండ్ నోట్ డౌన్ ద అమ్మీటర్ రీడింగ్. Note down the ammeter reading and note it in your notebook and record it in your record. So record lo dani book lo note cheyandi ammeter reading. So let us say when the length of the conductor is 10 centimeter, let us say ammeter reading, that means ammeter gives current, let us say it will be 0.1 amp or 0.5 amp. So now remove this 10 centimeter wire from P and Q and replace with 15 centimeter wire. That means length increases. So again switch on and measure the ammeter current. Let us say now it will be 15 centimeter. Measure the ammeter reading and record the ammeter reading. It will be, current will be decreases to some 0.3 amps. What will going to happen when length increases, current reading will be decreases, because when length increases, resistance length increases, so that means the conductor length increases, resistance increases. Resistance, when resistance increases, so flow of current will be decreases, because from the Ohm's law we have studied that the relation between voltage, current and resistance. Generally I is equal to V by R or R is equal to V by I, or inversely proportional to I. So if length increases, resistance increases. If resistance increases, current flow will be decreases. That means suppose if you are connected 10 centimeter, that will be 0.5 amp. Suppose if you are connected with 15 centimeter in this gap, so current will be 0.1. Suppose if you contact with another one, L is equal to let us say some 20 centimeter, current will be further decreases to some 0.1 amp. That means if resistance increases, that means length of the conductor increases, resistance in the conductor will be also increases, flow of current will be decreases, because R inversely proportional to I. So from this activity we can say that resistance always directly proportional to length. That means if length increases, resistance also increases, flow of current decreases. That's why ammeter reading will be decreases. So once again, so what is our activity? How do you prove that resistance of a conductor depends upon its length? So take conducting wires and one battery. So potential will be same here. We are not changing the potential. Ammeter and key. So initially there will be a gap between this P and Q. So circuit becomes open. Now this P and Q will be replaced with some manganese wire of 10 centimeter. So take different lengths of manganese wires, but the condition they should have same area of cross section. Area of cross section సమానంగా ఉండాలి. లెన్స్ మాత్రం డిఫరెంట్ గా ఉండాలి. మొదట 10 సెంటీమీటర్ ఫిక్స్ చేస్తాం, అమ్మీటర్ రీడింగ్ నోట్ చేయటం, తర్వాత 15 సెంటీమీటర్ రీప్లేస్ చేయటం, అమ్మీటర్ రీడింగ్ నోట్ చేయటం. అలా మనం చేసినట్టయితే if you are increasing the length of the conductor, current in the ammeter will be decreases because resistance will be increasing. Length increases, resistance increases, flow of current because R inversely proportional to I from Ohm's law. What we are studied in the Ohm's law, at constant temperature, voltage and current will be directly proportional. If current increases, voltage also increases, but temperature should be remains constant. So in this way, we can repeat this activity with different lengths. With length goes on increases, ammeter reading goes on decreases. That means if length increases, resistance also increases, flow of current decreases. This is our activity. So next activity, how do you prove that? Depends upon area of cross section. So next activity, how do you prove that resistance of a conductor depends upon area of cross section? Generally, we know that from the laws of resistance, R inversely proportional to A. Resistance inversely proportional to cross-sectional area. If area of cross-section increases, resistance of the conductor will be decreases, then flow of current will be increases. So for this activity also, so take some conducting wires and an ammeter and the key. These are the 2 points P and Q. Initially there is a gap, this becomes an open circuit. Now take manganese wires of same length. Now the conduction will be same length of wires, but different area of cross section. లెంత్ సేమ్ ఉండాలి, ఏరియా ఆఫ్ క్రాస్ సెక్షన్ డిఫరెంట్ ఉండాలి. అలాంటి మ్యాంగనీస్ వైర్స్ అని తీసుకుందాం. మొదట ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఫర్ ఎగ్జాంపుల్ 10 సెంటీమీటర్ స్క్వేర్, తర్వాత రెండోది 15 సెంటీమీటర్ స్క్వేర్, మూడోది మళ్ళీ అది కూడా మ్యాంగనీస్ వైరే, అన్ని మ్యాంగనీస్ ఒకే మెటీరియల్ 20 సెంటీమీటర్ స్క్వేర్, తర్వాత 25 సెంటీమీటర్ స్క్వేర్. ఇలాగా డిఫరెంట్ ఏరియా ఉన్నటువంటి లెంత్ మాత్రం సేమ్ ఉన్నటువంటి కండక్టర్స్ మ్యాంగనీస్ వైర్స్ ని తీసుకుని initially we connect a manganese wire of area of cross section 10 centimeter square. ఉన్న వైర్ మనం కనెక్ట్ చేద్దాం. కనెక్ట్ చేయండి between the points P and Q and press the key and measure the ammeter reading and note down the ammeter reading in your notebook. Okay, let us say, so the initially the ammeter reading when area of cross section will be 10 centimeter square, ammeter reading, ammeter gives current, so that current will be 0.5 amp. Okay, now replace this 10 centimeter square with 15 centimeter square area of cross section. That means area of cross section increases, but length will be same. Okay, if initially how much length we are using, the same length we are using, but area of cross section will be changed. So what will going to happen? Again press the key and measure. Now the area of cross section will be 15 centimeter square and measure the current. So area of cross section increases. Area of cross section increases, resistance decreases, and the flow of current increases because R again inversely proportional to I. If resistance will be increases, flow of current will be decreases. If resistance decreases, flow of current will be increases. Now area of cross section increases, resistance will be decreases, then current will be increases. Now it will be some 0.7 amp. Again it will be changes with 20 centimeter square. Now replace with 15 centimeter with 20 centimeter square in between P and Q and again measure the current. Press the key and measure the current. Now area of cross section will be 20 centimeter square and the reading of current will be some 0.9 amps. That means if area of cross section increases, so resistance will be decreases, flow of current increases. That's why the readings in ammeter will be gradually increases. If you are replacing with different cross section area, that means increasing in cross section area, resistance will be decreases, flow of current will be increases. From this activity we can prove that resistance of a conductor also depends upon area of cross section. Not only length and area of cross section, resistance also depends upon the temperature and also depends upon the nature of the substance. These are the laws of resistance. With the heat produced in these wires, when the voltage across each constant, voltage across each constant. So here two wires A and B. What are the condition? Length same and area of cross sectional areas in the ratio. Material also same, length same, but area of cross section. Let us say area of cross section of A is 1. Area of cross section will be B 4. AA is to AB is equal to 1 is to 4. So areas of cross section. What would be the ratio of heat produced? Let us say quantity of heat produced QA, quantity of heat produced in the wire QB. What is the ratio between them? So this will be the question mark. Okay. What is the relation between quantity of heat produced and the area of cross section? Let us say quantity from the loss of quantity of heat produced, there is Joule's law, Q directly proportional to I square, and also Q directly proportional to R resistance, and Q directly proportional to time of current flow T. So if you combine all of these, Q directly proportional to I square R T. So that means Q and I square are directly proportional. Q and I square. What is I square? Current. Squares of current. So I square R, time T is the time of current flow. So Q directly proportional to I square R. So Q is equal to I square R. So from the Ohm's law, it's a magic triangle. So V I R. I is equal to V by R. Generally V by R. That means V square by R square into R. Apply Ohm's law for this I. Then it becomes cancel. It becomes V square by R. Quantity of heat Q is equal to V square by R. That means Q and R are inversely proportional. But from the laws of resistance we know that R directly proportional to L, resistance of a conductor diagonal L, and inversely proportional to cross sectional area. If you combine this, R proportional to L by A. So R in play, R is equal to rho L by A. Rho is the specific resistance or resistivity of the material. Substitute in place of R rho L by A. Then Q becomes V square by rho L by A. Okay. So what is going to happen here? So Q is equal to V square A by rho L. That means Q and A, quantity of heat and cross sectional area are directly proportional. So our relation will be between quantity of heat and cross sectional area. Here Q directly proportional to A, or Q1 is equal to A1 or Q2 is equal to A2. Therefore Q1 by Q2 is equal to A1 by A2. That is 1 by 4, or Q1 is to Q2 is also equal to 1:4. That means what is the ratio between the heat produced the wires Q1, Q2 or QA, QB? Okay, QA, QB. We are given the names here. QA, QB, QA, QB. Okay. What is the ratio of heat produced between the wires A and B? Is again 1:4. Once again, two wires A and B length. Here length will be same, material will be same, but area of cross section will be is different. It will be on the ratio of 1:4. What would be the ratio of heat produced? That means quantity of heat produced in one of the wire. In A wire will be QA, another wire will be QB. Area of cross section of the first wire AA, second wire will be AB. It will be 1:4. In these wires, voltage across each will be constant. So from the relation Q directly proportional to I square R. From this relation, we are calculated the relation between Q and A is directly proportional. Therefore, QA by QB is equal to AA by AB. A1, A2 or AA, AB. Okay. So from this, we are calculated that the ratio between them, the heats produced between the wires A and B will be equal to 1:4. So this is the problem.